So today we're going to discuss the phases of the moon and what causes them, which is probably the most commonly ever done astronomical observation on this planet. You look up and you're like, oh, like 2 nights ago, I was like, oh, that's a really nice full moon tonight, things like that. So we're going to talk today about what causes the phases of the moon, things like that. It's a little bit of a geometric puzzle or conceptual thing that everybody has to rack their minds around. So it's going to be a little confusing for some people, but hopefully we can get through it together. Of course, we have an activity that should help solidify things, and we're going to have a demo today. So extra exciting stuff. So phases of the moon. So today's plan, we are going to discuss the phases of the moon. So what phases of the moon does the moon show? And in what particular order do they show it? The phases we're going to see are always going to go in the same order. We're going to discuss those phases. What time of day can you see these phases? You can't see all of the phases of the moon at every single time of day. The moon is not always up, right? Even if you want to look for it. And I'm going to help you guys with some tools to help you guys develop your understandings on how to figure out what the moon phase is. So to start, we were touching on this a little bit last week when we were talking about the phases of Venus. But the first important thing to do here is to discuss the different phases of the moon and the order that they happen in. So starting at wherever my mouse is, at the left and going to the right, we always start with a new moon phase. So that means we don't see the disk. Then we go into what is called waxing crescent. So the first half, these are all called waxing phases until you get to full. And then we have the crescent, the first quarter, and then waxing gibbous when it's between these two. I will also point out, if you're trying to remember the difference between waxing and waning, which is the other half, my little mnemonic on how I do that is, so the right side here, I kind of imagine it looks like a D, right? If it was a capital D on that side. So that is the developing phase. It's when the moon is getting bigger. So when you see the D, think developing, and that's how you remember it's the one that's getting bigger still, the waxing phase. So we go through, then we get to the full phase when, of course, the disk is completely illuminated for the moon. And then we start waning. We basically go through the exact same phases as before, but we're going to go through waning gibbous, the third quarter, followed by the waning crescent. If you're a mathematical-minded person, the way I like to also define these, if this helps, is the new moon is 0% illuminated. Then we have the crescent phase, which is less than 50%. Half is 100. Half is 50%. Gibbous is 50 to almost 100, not quite 100%, because 100% is full. If this does not help you remember the order, that's perfectly fine. It's just some people really prefer to think about this in terms of what's the definition in terms of numbers. So I can also show you guys a GIF of what the moon looks like as it's going through these phases. So this is what the moon does every single month as it's going through its phases. We start with nothing illuminated. We start on the right. It is developing. It becomes a full moon. And then the light starts going toward the other side. It starts waning. And then eventually we get back to that new moon phase and the cycle begins anew. Side note, if you're wondering why the moon itself, like the features on the moon, are doing this little dance, it turns out the moon, its rotation is basically exactly the same as its rotation like on its axis. So a lunar day is as long as it takes for it to go around the Earth. So we basically only see one side is what causes this. We're going to talk more about this when we discuss what the moon is made of and things like that later in the class. But that does give it this interesting look because we're not seeing the full moon as it goes through this little dance. So now that we know the definitions of the different moon phases, we can start discussing what is causing these moon phases. So if we imagine we're outside of the plane of our solar system on the north, looking down toward Earth, so looking down at the north pole of the planet, over here on the left, we have our sunlight coming from our sun. And in this direction, we have our Earth here. Half of the Earth at any given point is illuminated by the sun, 50%. And then if we look at the orbit of the moon around the Earth, it of course goes in a circle, as we said, every 27-ish days. So the thing you have to think about is in this context, we are, of course, here on Earth. The sunlight is coming from here. So the questions are, in all of these different parts of the moon's orbit, which side of the moon is illuminated and which side of the moon do we see? These are not obviously always the same thing. To give you an example, right here, we have the moon at this certain point in its orbit. So this half of the moon is illuminated, this half of the moon is not illuminated. So we're going to do a B, C, D test here. Which side of the moon or do we see, or which phase then do you think that we see in this case? Okay, I'm seeing a sea of A's out there, and that is great because yes, we see the new moon when the moon is between us and the sun. So that one's pretty good. And then of course, it's pretty easy then to say like, okay, this one's pretty straightforward. That's the new moon. This then is going to be the full moon when the moon is completely illuminated by the sun because it's opposite the sun. So we see that full 50% disk to us is 100% at our distance. So here's another question for you. At what time of day is this phase then going to be the highest in the sky? If you were an observer facing the new moon directly, what time of day do you think this happens? So your options are 6 a.m., noon, 6 p.m., or midnight. So let's see those cards again. When you're on this side of the Earth, you can see the little observer here in this figure. He is in the sunshine side of the planet, right? He's actually, in fact, exactly in the middle. So that's pretty much going to be noon, as we discussed in our last class. So the new moon happens during the daytime. Not like it's very easy to see the new moon because it's not illuminated, but it's up there, even if you can't see it. And yes, on the other hand, if it was the full moon is up, basically up all night because you would be standing basically on this side of the Earth. One final question for you. Okay, first of all, I'm going to point out in our little Earth here, we have, of course, our axis of rotation. And this is going toward the west. This is the east, but the Earth is rotating this way because, of course, the sun sets in the west. So can you see this phase, the new moon phase at sunset? Okay, I'm seeing a little more B than A. Good job, the B's have it. Eventually, it's no longer going to be up. And yeah, there's no illumination to be seen. So as I said, the new moon, the full moon, those are the easy ones. I'd argue that the first quarter and third quarter are also fairly straightforward ones. You have to think about it a little bit more, but you guys could probably figure it out. But then we have some more complicated phases in the middle. So it's still the same questions though. Which side is illuminated versus which side you see? So here's the full moon, but then we have, as I said, all these other ones. So what we're going to think about is I have these spheres here, and we're looking at a moon that is here, not quite a new moon. The first question here is, which of these figures here shows the correct direction of sunlight on the moon? Alrighty, I see a sea of C's out there, which is correct. So the moon has an axis, the Earth has an axis, but half of the moon is always being illuminated by the sun, and it's going to be perpendicular to the direction of that light. It would not make very much sense if this part was in the sun and was not illuminated. Does not make sense that the part of the moon that is not facing the sun would be illuminated, and that's the same for D. Now here's another question for you. In that same setup, the moon is there. We just discussed what side is illuminated. Which of these phases is seen by this observer on Earth? So standing here, looking at the moon, which is here in its orbit. Okay, I see pretty much everybody chose crescent, which is great. And the majority of people chose the correct answer, which is waxing crescent. And so finally, to wrap this up, time highest in the sky. We have the same observer. I'm going to remind you, this is the rotation of the Earth and the east and west directions. What time is that phase, that waxing crescent phase, highest in the sky? So if you're an observer facing the moon directly. I'd say the C's have it looking out there, which is correct. Afternoon is when you're most likely to see that crescent phase. Another way to think of this, so this is just an observational thing. You can often see a sunset and see a beautiful little crescent moon in your sunset sky, right? So that means that it's an afternoon object to get that phase, to be able to see it at sunset. I mean, there's also a waning crescent in the morning sky, but you guys are in college. You're usually not up early enough to see the sunrise, I think. So, waxing crescent is the one that you're seeing at sunset, is another way to keep that in mind. Remember the order that things are going in. So we're going to have one final test here. So the observer's time of day is blank. This moon phase is toward blank of their zenith. Zenith means directly overhead. They either can or cannot see this phase. So here's the observer. Here's the Earth's rotation. Here's this phase. So have a think about what time it must be for the observer and if they could see this phase or not. All righty. Yeah, I see C's and D's out there primarily. The C's have it this time. So the fact that it's pretty laid out, I mean, he's standing on the dark side of the planet. So that's kind of a giveaway that it's got probably not 6 p.m. I mean, unless it's winter time up here, you usually still have daylight at 6 p.m., like even right now, for example. So 9 p.m. makes more sense. This is the direction of the west, I just told you. So the west should be your correct choice in that terms. And yes, you cannot see, in this particular case, the phase of this moon here, because the sun is already set. And as I said, you usually see that little crescent moon pretty close to that sunset. So usually after an hour or two, it's gone. So as I'm sure you guys have realized, and also we showed in our demo, this takes a lot of 3D thinking skills to kind of work around what exactly is happening, building a mental model of what is happening between these three bodies to figure out what kind of phase it is, what type of day it is. So I have a couple tools that we're going to use also in this activity that we're going to start shortly, that I'm going to go through first to help you guys build this mental map and understand it. These are, of course, going to be on Canvas afterward. So the first thing here is this is going to be a good tool if you're not entirely certain of how this works and you want to play around with more examples like this. So this is going to be on Canvas, and this is a moon phase tool. It's basically this general printout just on a Google Sheet. And what you're going to be able to do is you can make a map. So you're going to be able to drag the phases to the order that you think they're in. You can also rotate the observer to certain points and then copy paste phase images of the sun and think about where the sun must be in the sky. So if you're having trouble with a homework question, something like that, go to this sheet, start playing around with it, see if you can figure out the answer. It can get pretty complicated if you're just trying to do it all in your head. So the second thing that I'm going to show you guys is we also have, simulators, of course, on the internet these days to tell us about lunar phases. So this particular one is what we're going to be using very soon in our activity. So we're going to start with the new moon. We have our observer here. This should look very familiar on Earth. The sunlight is coming from this direction. And we also have here the horizon diagram. So it's the observer's local time at 12 p.m. and you can see where the sun is, everything like that. So I'm going to start this animation. And you can see our observer is spinning around. So once a day, of course, he spins around. And you can see here that the moon is moving and the phase of the moon is also rising. So it's a waxing crescent right now, it tells you. So it is developing. And then we are going to get to a half moon phase here. So the first quarter moon or half moon. Then, of course, we now have the gibbous phase, still waxing. So still a waxing gibbous because it is still growing or developing. And then we are eventually going to, as it gets over here, be in that full moon phase. But also I can stop this, I think, yes, at any point. So you can think like, okay, this is the phase of the moon. Here's the observer's local time. This is maybe not the best. So this is dark right now. Here is the moon, the little gray one. Here's the sun is the little yellow one going around. So you can also just literally look and say, can I see what is going on in terms of is the sun and are the sun and the moon in the same sky at the same time? I can also pause to look, okay, this is 4:20 p.m. I see the sun, I don't see the moon, things like that. You can work through and sort out what exactly all these relations are like. So I should also point out, we can also do the simulator, but you can, as I said, sketch this out yourself. It depends what you're comfortable with to sort out these things. So just to wrap up, today was the phases of the moon. I think it was worth drilling down into to make sure you guys understand it and how it works.